Hello.
Hello there.
Welcome to the 5th day of
Advent.
Our Codemas Advent Code videos for Orion Robots. And today I've got Phoebe back with me.
Yeah, I'm
Phoebe,
back.
do the honours.
Yes, I shall. And this time there'll be no fumbling because I'm not going to do that for another 5 minutes. Such a waste of my
What have we
time.
got? That's a sounder, as in a beeper,
It's a buzzer.
Speaker. Yeah,
It
I think
does
it's a
the sound.
speaker.
So what are we going to do with this sound making?
Daily Box Guides 4.
It's day 5.
It is day 5.
Daily box guides.
Day
5.
5. Daily Box Guides, day 5. Yeah, we're so leaving that into outtakes. All right, hear my code. Hear my code.
You're welcome.
Welcome to day 5. We're going to use a custom buzzer that you've just discovered in your box. It is a nice buzzer. It is a nice buzzer. So we can add so much to a project with audible feedback. Hold on. So we've got a dial and a pico and a feedback. And let's construct it. So made sure it's unplugged. And we've left the potentiometer in. So we're going to leave that in place. And we'll put the buzzer in. It's good to go. There we go. Those two pins up there.
Oh, with the LEDs that I totally didn't place badly.
Okay, activity 1. Let's buzz. So we talked a little bit yesterday about PWM and how you were using PWM duty cycle to control the brightness of LEDs. But if we control the PWM frequency, we can
control sound. Now this is my kind of tech.
So the duty cycle, which we mentioned yesterday, is the volume of the buzzer. Frequency changes the tone of the buzzer. So we can change tone and volume, and we can put sleeps in. All right, so we're going to copy this example into Thonny. Here's Thonny. Let's go connect the Pico, because we're not going to get very far without that. When we hit the run current script, we have to go and save it. We'll call it
Day 5.
Day 5, and we'll call it beep.py.
It did exactly what you said.
It did. It beeped pretty quickly. There was pretty much no warning. Well, I say no warning. I did hit the play button. If I change this value...
No,
Oh, no, that's the duty
you have
cycle.
to change the frequency. I think that just broke my ears.
But we just did an octave. 440, 880. Did you know that an octave was exactly double the frequency?
No.
You do now. Give or take.
That's terrible. It's not up an octave.
That's not a what?
It's not up an octave.
Okay, so anyway, we got a beep. That was nice. And they said frequency number 300, see what happens. We did that anyway. If you do it too high, your human ears won't hear it. But we could always annoy the smaller children. Changing tones. Day 5. Beep. Boop. .py.
You're very creative.
You love my naming, don't you?
That was such a sad beep boop.
I know, well, you know, kind of, yeah.
What if you made it like 501?
You wouldn't hear it. You would not hear a 1. Whereas if I made it 550, you'd probably hear it. That made your teeth feel bad, didn't it?
No, it didn't. That made your teeth feel bad.
Right. Potentiometer volume control. Warning, this one's a bit noisy.
Perfect.
If you find it too loud or harsh, you can always put some blue tack over the hole to calm it down.
No.
Right. So readings for potentiometer are between 0 and 65535.
I thought this was going to say play some sticky tape or blue tack in your ears.
That is never a good idea. Don't ever do that.
That's
Right.
what I thought. Don't ever live with
A little bit of warning. This will never turn off even if you stop the program. You could unplug or just move on. Do you know, that little bit of warning is quite nice. So what I'm going to do is I'm going to keep the beep boop thing open so I can quickly go and run that instead. Do you know what we're going to call this? We're going to call this...
unending beep.
Okay. I was just going to call it noisy. But yeah, unending beep. Okay.
I have better names than you. Fight me. My ears.
My ears are ringing, and that's not because it's Christmas. Next one.
Merry Christmas.
Merry Christmas. Oh.
Yep.
The other thing you heard there is it wasn't just changing the volume. There was some pitch anomalies going on there as well.
Frequency changes.
Yeah.
Very subtly, but also very not subtly to our ears.
And that's because it's the difference between a tone, and then with some of these half angles, you end up with some other, what can I call them, harmonics, extra tones you can hear as well.
Yes.
Yeah. Festive jingle.
Are we going to make it do jingle bells?
Musical note frequency is a variable using the note names. Okay. Jingle bells. It's a bit flat. The notes are all kind of the same length.
That's because the song is flat.
Maybe.
There's one note for half of it.
So what they're doing, they're setting the frequency to turn on the buzzer. So they're turning on the buzzer, sleeping, then setting this to turn off the buzzer and then sleeping again. So that's when you get beep, beep, beep. So you've got rests between the sounds.
Yep.
Cool. And you've got jingle bells. Okay, so they've kind of shown each other. This is quite a lot of code. However, the very next thing they did to use functions.
Hey.
So functions are a way of creating reusable blocks. I am not going to read all the way through that, just to say they are a key programming element.
This is a function.
And the other thing about a function is once you've got one, you can kind of grow on it and make it do all interesting things. You can give them arguments, so you can tell them how to use its things, as in if a function's got a purpose, you can give that purpose some different directions, so it doesn't have
Like some variables inside the function, but not quite.
We're going to have a function here called playtone. Still only got 4 notes.
I mean, Jingle Bells only has 4 notes. It's so simple.
Yeah, true. Smart jingle. Jingle.py, jingle.py.
When did that start sounding,
The reason it sounds crickety is because they've made the volume variable lower.
No, then make it higher.
So what did they set it to in
Last
day
time.
5 jingle? They created actually 10,000, which didn't have the same anomaly.
We could have just written 10,000. Oh, there's the fun in that. Okay.
That sounds better.
Sounds
Yeah, as it gets louder, there will be places where it's going to do this, because if it's very close to the end, you've only got a thin amount of time that's off for.
Mm-hmm.
So that's going to kind of sound like, well, some stuff randomly chorded together. Using that playtone function, and we got playtones here. Dub, 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 dub. Okay, bonus. They said more notes, so we can get creative, and then we'll be complete. Well, we're going to take Smart Jingle, and we're going to make a new file here.
With a song of our choice.
With a song of our choice, a set of tone variables. I'll just knock that out. And we're
We'll
going
add
to...
the rest.
Yeah, they've got a whole bunch of notes here.
Just nab them all.
Yeah, pretty much. And look, I already went for 440, which is apparently A. C's 523. Okay. Are those the same notes we've already got? Yeah, they are. I like the fact that I was able to copy paste from that list and it pastes right in as variable definitions here. That's
that was useful.
very nice. Now, the way you can do another octave.
Is you copy the rest and add some crazy number.
Well, it's even better than that.
A2.
Okay, wait a second. It's a computer, right?
Well, you don't say.
It has the power to compute.
Uh-huh. Unlike me. Can you make a split in between those?
Yeah, sure.
Thank you.
An octave, as I pointed out earlier, is twice the frequency.
Of the last octave.
Yep.
Oh, okay. That's so much more simple than I thought.
2 octaves should be enough for us to create any song we like. And
We'll be right back.
we'll be right back.
We've got something to show you because we've been messing around with this for about 10 minutes.
Mm-hmm. And we're not going to reveal the notes to you, but we will play our own tune.
Yeah, it's very original as well.
We thank you very much.
And have a very Merry Christmas until we see you tomorrow.
Bye. Read my mind.